Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirabbil alamin wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Insyaallah today we will be continuing to our second chapter on BQS554, which is in regard to the topic of electricity. Today we will cover the topics of what electricity actually is, the sources of electricity. There are four. We take the first one, okay? Electricity generation. Other three parts we will continue inshallah next week. What is actually electricity? It's a flow of electric charge along a wire. The more charge that are passing along the wire with the larger current. It's just a flow of electric charge along a conductive wire. The more the flow, we think that the larger the current of the electricity. And obviously, the larger current of electricity would require a larger conductive wire for it to flow on. We have two types of electric charge, the positive and the negative. We have the Coulomb's law as magnitude of force. Okay, and then this represents the quantity of electricity. We will not tackle this topic as, let's say, the electrical students are handling it. We just are going to browse through the definitions. We are more interested on the system that are established for the supply of electricity. But if you are interested in understanding the basic principles of electricity, I would suggest for you to look for training videos online, YouTube and such. There is a lot, okay, that you can learn online. The electric current is a flow of electron along a conductor that is forced by a generator or a battery to a consuming device. Based on that definition, it covers the four main components that involve in the flow of electrical current. First of all, we must have electron, the positive or negatively charged, is moving along a conductor. Okay, a conductor is a medium that allows the electron to flow without much resistance, because this electron would find the path with the least resistance for it to flow. What is that? What is the component that allows this electron to move or to flow in the first place? Is the generator, or what we call it as the battery. So this battery is forcing the electron to move through this conductor, and we must have the consuming device or the load. The electron must go to this load before it returns back to the source, meaning that the generator itself. So with these four components, we have a complete loop of electrical current. So it's important for us to ensure that when we are using electricity, there is a load. So kalau tak ada load ni, it can be quite dangerous. That is the schematic drawing of current flow or in an electrical circuit. And they have their own standard icons for each of the components. The switch, okay, that it's like the disconnected line. The zigzag is actually the resistance, and the bar there is the generator or the battery. So when as a QS, going through the drawings and you come up with schematic for electrical installation, you might come across this type of symbols. The basis of electricity, we have two types, AC and DC. Bukan AC-DC rock group It's actually alternating current and direct current. Meaning that the flow tu lah, the flow of electron tu, either it flows both ways, that is the alternating current. It flows one way and then it reverses back to the other way and it goes back the original way, so they alternate. Or the direct current, the electron flows in one way. It does not flow back. Alternating current varies periodically in value and direction. Of course, it changes values, and also in terms of its value also changes. It is more economical ability to change the voltage levels by using transformers. Again, this transformer is a device that you use to change the voltage of the alternating current. This is exclusively for alternating current because when the alternating current has been produced, for it to be transferred over long distances, we need to boost up the voltage. We can only do that by using the step-up transformer. When it reaches where it's intended to be, it will be going through the step-down transformer before going to another series of step-down transformer before passing it through to the users. This is the unique characteristic of alternating current. There is a great history between this AC and DC current. Next is direct current. The direct current has a constant flow of electron in one way. So it's completely the opposite. The value does not change that much and it is only flowing in one direction. So suitable for low voltage application such as battery powered appliances. There's a great history on AC and DC. Both were actually discovered but promoted by two competing inventors. The AC was popularized by Nikola Tesla. He is an inventor, but unfortunately he is not a businessman. So he tries to, at that time America was starting to develop. It needs electricity to power its town and whatnot. Tesla was promoting AC to be used in towns in America. But at the same time, there is another inventor that is promoting DC, okay? So direct current, who is Thomas Alva Edison. So he is a so-called inventor, but he is also a businessman. So both of them really fought for each other. Thomas Alva Edison was promoting direct current. Tesla was promoting alternating current, which was the system that we are using now. The beauty of alternating current is that we can transmit it over long distances without the need of a lot of these substations. But if we use direct current, we would need a lot of substations before reaching where the electricity is needed because it is direct current, it is low voltage. There was an incident where, to prove his point, Mr. Edison, he wants to show the danger of using alternating current. He made a demonstration of electrocuting an elephant with AC. So he was trying to downplay the AC technology that was promoted by Tesla. And that did happen, but due to the advantages of AC, so the world has adopted AC to power up their towns and cities. That was a loss for Mr. Edison. So people take up AC to power their cities. However, Nikola Tesla did not benefit much from that. He did very bad in business deals and he died as a poor man. Yeah, it's a good thing to be an inventor, but you have also to be a business oriented inventor. But however, if you read more on Tesla, he is very interesting fella. He has predicted the transfer of electricity without wires, on which what we are using today. We are charging our phones without any wires, right? He has predicted our era back in the old times. And his vision does not just stop there. He envisioned that the transmission of electricity, AC, which these days we transmit using very long cables through towers and whatnot, that can also be done wirelessly. So bayangkan transmission of AC power yang beratus ribu volt tu menggunakan wireless transmission tower tanpa menggunakan kabel sama sekali. So that's how far his vision is. This is very significant because electricity is the basic requirement of the modern world. So without electricity, we will not have all this technology. Okay? We will not have electronic, we will not have computers, we will not have all these things, communication, because the backbone of the new world is electricity. Without electricity, we'll be like back pada zaman-zaman dulu lah. Alright, so that is on AC and DC. Very interesting topic. I like it very much. Terminology of electricity, ampere, is a unit of the rate of flow of an electric current. Okay, 1 ampere represents a current flow of 1 coulomb of charge per second. To imagine this thing, we can see it as like water going through your typical garden hose. How much water is flowing through your garden hose per second? Something like that. Okay. So that's the ampere. So obviously, the higher the amperage, okay, the more dangerous, okay, the electricity is. Then we have the volts, electrical force that causes free electron to flow along a conductor, and ohm is the resistance of that conductor. Normally for conductor, the lower the resistance, the better it is. So that is why in cables, wires, the inside of the cables, they use copper because copper has the lowest electrical resistance compared to any other metals. Hmm? And also that's why wireless technology did not really pick up because one, they did not pick up the Tesla's research on wireless transmission. You know, when he died, he died by, unfortunately, he was struck by a car. He was doing his research on wireless transmission of electricity. Either the authorities found his papers and locked it up somewhere, or they just don't know how to continue on that. Okay. So wireless technology, because if the electricity has to go through the air, it has a lot of resistance to overcome. So that's why transmission through cable is a lot more easier. So these are some of the formulas. If you can still remember your school days, belajar fizik. Okay. V equals IR. Okay. Voltage equals current times resistance. Okay, so these are some of the definitions. Conductor, a material where electric current flows. So normally we use copper and aluminium. Sometimes if we look at the head socket, the metal that they use are silver in color. So that is not copper. That is most probably aluminium, which has a higher resistance but still can be used. Because copper these days, they are very expensive. Because copper has a high demand in electricity industry and electronics. Good conductors have low low resistance to the flow of electricity. Insulator is the opposite of conductor. Insulator do not allows for the flow of electron through it. It does not conduct electricity. For example, glass, ceramic, and plastics. It does not allow current to flow. So that's why in cables, we have the core, the copper core, and then we have layers of insulation that will not allow electricity to pass through that cable. Kalau tidak, macam nak pegang. But it's different with bus bar. Bus bar is just the copper piece. Dia kepingan copper yang dia letak dalam riser and it is secured, maksudnya ditutup. Orang tak boleh buka. Okay, sebab dia exposed, terdedah. Dari segi ketahanan of this insulator, plastic is the lowest lah. Plastic, rubber. Okay, it can fail due to high heat. This is especially when you have your wires, especially these days, wires untuk pemasangan rumah, it has a very thin copper core. So when you load it up with a lot of electricity, it will heat up very fast. Okay, macam hose air itulah. Kan? Bayangkan you guna hose getah you untuk handle air daripada truck bomba. Obviously, your hose is going to burst because of the amount of water that's coming in. Your rubber hose cannot handle it. Same goes with electricity. If we have a very tiny core, but the amount of electricity that comes in is exceed the capability of that wire, that core is going to rise in temperature. So your insulator, the rubber or plastic insulator, will also increase in temperature. It will melt, it will crack. So your copper core terdedah pada udara dan bila kena rafter bumbung daripada kayu dan sebagainya, ceiling, akan berlaku kebakaran. Itu yang kita tengok kalau dalam berita tu kan, Punca kebakaran akibat litar pintas lah, whatever. Kan? Litar pintas tu lah punca dia. Kita load up that wire lebih daripada sepatutnya. So that's why kalau extension wire tu janganlah pergi sambung sampai 10 device kan. So habislah kan extension tu, sebab you are pulling so much electricity through that tiny cable. For applications that would usually result in high heat, such as transmission over pylon dan sebagainya, they will not use plastics as insulator. TMB kan, TMB, KTM, kalau kita tengok wire bervoltan tinggi tu, yang ada benda bulat-bulat macam tu, itu adalah seramik. So seramik pun insulator, dia tahan kabel, tapi dia mudah pecah. Okay? Sama juga dengan glass. Dia ada kesesuaian dia lah. And then they are used on electrical device to provide protection. Power and energy term used to express work, kilowatt hour. Berapa kilowatt jam? This is very important for you to know. Kan, time-time PKP ni orang duk complain bil api duk naik. Of course, what do you expect? Kan, you are using your appliances 24/7 in your house. Kan? To make things worse, you have a lot of electrical appliances, high-powered electrical appliances at your house. Macam nak tahu? Tengok dia punya spec of your electrical appliances. How much wattage of power it consumes in 1 hour. Dia kan ada duration kat situ. One of the highest consumption of power. Power is the watt itself, but when we want to measure work, it must be kilowatt jam. Dia mesti ada jam kat situ. So, kalau you check the power, ni power saja, power rating of your appliances. Katakan yang paling tinggi kalau you ada lah is water boiler. Ataupun chariot elektrik, ataupun water heater mandi tu, itu memang consumption dia cukup tinggi, mencecah hingga 1000 watt. Tapi dari segi penggunaan, katakan chariot elektrik ni, you guna dia berapa lama sangat? 1 jam kan? So sebab tu the element of duration tu kena ada. Walaupun dia 1000 watt, tapi kita guna dia beberapa minit saja. Berbanding dengan fridge tu tadi kan, katakan berapa, 400, 500 watt, tapi dia punya duration tu 24 jam kan. Obviously dari segi the use of energy, walaupun dari segi power consumption, your fridge tu tak setinggi chariot elektrik, tapi because of the duration, it consumes a lot of energy. Okay? Kadang-kadang try banding dengan you punya lampu pula kan, especially LED lights kan. Berapa watt sangat? 3 kilowatt 3 kilowatt 3 watt, 2 watt kan. Walaupun you guna untuk tempoh masa yang lama, but because of the low wattage, it does not really affect your energy consumption. So that's why you have to be very particular. Me myself, saya tanda my electrical appliances ni berapa watt, ini berapa watt, ini berapa watt, supaya I know equipment ataupun appliances yang high wattage tu kita tak boleh guna dia untuk tempoh masa yang terlalu lama. Belum cerita aircon lagi. Those are the kind of things that you have to really look into Okay, time BKP. Next is the transformer. Transformer is unique feature of AC. It allows for the distribution of AC over long distances efficiently. Okay. So it has a primary input and a secondary output. Boleh tak apa? Okay, around a common metal loop and the respective number of windings. Okay. So if it's a step up transformer, dia punya loop of dia punya input is less than the output loop. That means that it is stepping up the voltage. If the voltage is being stepped down, it's the other way. The input loops are a lot more than the output loops. And this transformer operates at a very high temperature. So that's why if it has its own cooling system, then dia punya insulator pun bukan daripada plastik tak main dah. Alright, so we are done with the terms and whatnot. Now we move on into the electrical supply system. So the electrical supply system involves four main processes. We have the generation, transmission, distribution, and the actual supply. So there are four stages in making sure that the end user has the supply of electricity. First, the generation of electricity. Next, the transmission of electricity over long distances. Next, the distribution of electricity to the local area, to the users of the local area. And then next, the actual supply from the distribution network into the building itself. So inshallah today we look into generation dulu lah. So this is a schematic of the entire process. If you look at the schematics, ada macam-macam ini pun another schematic. It doesn't really matter. What matters is that you can identify the four phases at this type of schematic drawing. We have this here is the power station. This part, the power station itself, it doesn't matter what type of power station, as long as it generate electricity. This is the first phase, the generation. Normally this power station, it will provide a 25 kilovolt electricity, alternating current electricity, which is 25,000 volts. That's a lot of volts. After this cable of 25 kilovolts, the next phase is the transmission. So even though this 25 kilovolts sounds a lot, but it is not, especially for long transmissions. So what we need to do is to boost up this voltage into, depends on the demand lah, 275 kilovolts or 400 kilovolts. That's 400,000 volts. Kita guna berapa volt? Kata ke appliance rumah kita guna berapa volt? Kan duduk rumah dah lama kan? You perhati tak apa yang ada kat rumah? Di Malaysia kita menggunakan appliances between 220 and 240 volts. So you bayangkan beza 220 dengan 400,000. It's very, very high. So to do that, we need a step-up transformer that will boost the voltage from 25 kilovolts to up to 400 kilovolts. So daripada sini bermula stage of transmission. These cables will go very long distances over this, what we call it, the pylon towers. Kalau kita drive kat highway tu, kadang-kadang kita boleh nampak these towers yang holding up this transmission cable. Bila they travel long distances, katakan dia dah sampai ke mana ia diperlukan. And then we have this step down transformer. Walaupun tak tulis kat sini, kita tahulah this is a step down transformer. In this case, dia akan kurangkan daripada 400 ataupun 275 kV to 132 kV. Dia turunkan. Sebab kalau terlalu tinggi, orang tak boleh guna. I believe this is the starting point of distribution. Distribution maksudnya electricity tu akan disebarkan ataupun diedarkan kepada pengguna-pengguna di kawasan itu saja. So obviously transmission line ni adalah dia supply bandar kawasan ni, and then dia pergi lagi other areas, dia supply kawasan tu pula. This is satu contoh kawasan saja. So when the power has been stepped down, di situ bermula proses distribution of electricity for that particular area. So bila dah turun ke 132 kilovolts, dia akan bergerak lagi di kawasan tersebut, and then diturunkan lagi ke 33 kilovolts, 33,000 volts. Siapa yang guna 33 kilovolt electricity ni? They are the kilang-kilang. Bukan kilang biasa ni. Ni heavy industry. Contoh kilang melebur besi. Kalau dia menggunakan electric furnace, kilang-kilang macam ni, dia punya demand in power ni sangat-sangat tinggi. So dia akan ambil 33 kilovolt direct. And then 33 kilovolt ni juga boleh dihantar ke town substation. 33 kilovolt ni is strong enough to power an entire town, a small town. Okay, so you bayangkan kilang melebur tu guna berapa banyak energy, cukup untuk supply a small town. When it's being sent to town substation, obviously boleh digunakan untuk bekalan elektrik untuk pekan tu lah. This 33 kilovolt boleh diturunkan lagi untuk pengguna-pengguna yang memerlukan 25 kilovolt, such as kereta api elektrik. Kereta api elektrik dia menggunakan tenaga elektrik yang agak tinggi lah. Kadang-kadang kita naik this ETS kan, dia sampai satu kawasan tu dia macam dia slow down, and then tahu-tahu dia padam. Dia padam, gegak-gegak, dia on balik. Tu dia sedang switch from one transformer to another transformer. Maksudnya satu line tu, ni satu transformer yang supply, line seterusnya transformer ni yang supply, sebab train has to travel long distances kan. So dia sedang tukar dia punya electrical supply from one transformer to another. Untuk railway kat sini, in this design dia ada turunkan lagi 33 kilovolt turun ke 11 kilovolt. 11 kilovolt untuk light industry. Okay, light industry 11 kilovolt ni pun kira tinggi lagi ni. Untuk kilang-kilang heavy light industries, bangunan-bangunan hospital, memerlukan tenaga elektrik yang agak tinggi, 11 kilovolt. Dan 11 kilovolt ni pun boleh digunakan untuk supply kampung. Kampung-kampung semua boleh guna 11 kilovolt. So the electricity travel lagi hinggalah sampai ke farms, small commercial buildings, kedai commercial building lah, bangunan-bangunan building macam hotel. Biasanya kita tengok dekat bangunan-bangunan ni, sebiji ni, dekat bahagian bawah tu dia ada substation dia sendiri. Bangunan tu, dia punya substation tu dalam bangunan tu warna kelabu. Tu dia punya own step down transformer. Kat situ dia kurangkan lagi daripada 11,000 volt ke 400 volt. Actually 415. Ini untuk kegunaan bangunan tu ataupun farms pun boleh lah. Untuk pengguna biasa macam kita ni, rumah-rumah, kedai biasa lah kan, dia akan turunkan lagi 400 volt, turunkan lagi ke 220 ke 240 volt, turunkan lagi, barulah boleh digunakan oleh pengguna rumah, end user lah, rumah kedai dan sebagainya. That is how, maksudnya dari segi line tu dah start maksudnya line tu dah sampai ke meter bacaan TMB tu, maksudnya proses distribution tu tamat kat situ. Going inside the building is already supply lah. That is the process of generation, transmission, distribution and supply. Kalau you all faham tu, whatever schematic diagram yang you dapat, you boleh understand lah. You boleh pecah-pecahkan dia. Macam ni pun dia kurang tepat. Dia generation station ni dia masukkan juga dalam transmission, which is in this definition not really. This is power generation. Bila sampai ke step up transformer tu, mulalah transmission kan. Transmission, travel. And then step down, maksudnya kita dah mula proses distribution in that localized area. Okay, and then goes through substation, okay, hantar ke pengguna industri, hantar ke pengguna commercial, hantar ke pekan, ke kampung, okay, goes down. And then bila dah sampai ke kawasan yang rendah ni, sampai ini pun tak betul. Mana ada 415 kilovolt kan, berasap lah orang punya TV kan. 415 ni untuk pengguna-pengguna komersial, bangunan hotel, hospital dan sebagainya. So bila step down 240 baru boleh digunakan oleh pengguna-pengguna biasa macam rumah-rumah, rumah kedai dan sebagainya. Bila sampai di situ, maksudnya sampai ke dia punya meter, bermula proses of supply to the consumer. Alright, next we move on to electricity generation. Okay, the first phase. Electricity generation is the first process in the delivery of electricity to consumers. We need to generate electricity. It is not something that is available naturally. It involves the generation of electricity. Electricity is generated in power stations by the use of different types of sources such as water or hydroelectric generation, steam, gas, solar, nuclear and battery power. So at the power station, electric power is produced at 11 to 20, even 25 kilovolt at 50 Hz frequency. 50 Hz ni representing how fast the electricity is travelling back and forth in 1 second. Most power station alternators, this power station has a huge alternator. This alternator ni macam, tak tahu lah orang sekarang guna lagi tak, generator basikal tu. Dynamo basikal tu yang apa, kena dekat tayar tu kan. So when we spin an electrical loop around a magnet, we are creating electricity. So the concept is same with that bicycle dynamo, is just it is being upscaled. Kejap lagi kita tengok gambar dia lah. What's important here is to turn that alternator so electricity can be generated. So the force that is needed to move that alternator can be anything. Either you go with water, hydroelectric. Normally, they will go by steam. Okay, the steam part will turn the alternator to generate electricity. How do you get that steam? Depends. If you are using coal, okay, that's a possibility. So you use coal to heat up the water. Water generates steam. Steam will turn the alternator. However, the use of coal is what you call, it's not very friendly to the environment. However, it's the cheapest. Okay? It's the easiest technology to construct. You can also use, besides coal, you can use gas, natural gas, which is a bit better to generate steam. We can also go for nuclear. To station jana kuasa nuklear tu, they are not using nuclear directly to produce electricity. They use nuclear to heat up the water that will generate steam that will turn the alternator. Itu sebenarnya. When you use nuclear to heat up the steam, obviously you will not run out of fuel for like 50 years, 60 years. Whereas if you use fossil fuel like coal or gas, you will need tremendous amount of those kind of fuel. And also there's a new type of source for generating steam, which is the solar or geothermal. So we use the power of the sun to heat up water, which generates steam. Or we can use geothermal. However, the use of geothermal methods would limit the size of your alternator. You cannot be, mass producing electricity by using this type of sources. So dia lebih kepada localized, berskala kecil. Katakan bekalan elektrik untuk satu pekan kecil. Itu boleh untuk guna solar ataupun geothermal. Dia tak boleh nak upscale lagi, not yet. And hydroelectric ni ialah menggunakan aliran air, sama ada biasanya melalui air sungai yang kita ampang, that generates tenaga upayaan which will move the turbine and the alternator. Other methods, dia menggunakan sea, okay, ombak. Ombak akan menggerakkan these flaps. That flaps is going to turn the what you call the alternators to generate electricity. Ni yang bagusnya kaedah ni, tak perlukan steam lah. Nak generate steam requires a lot of energy. So dia terus directly menggunakan tenaga keupayaan pada tenaga kinetik, terus generate electricity. Another one is using of wind. So wind turbines dan sebagainya pun menggunakan tenaga keupayaan from the wind directly untuk menggerakkan alternator. However, this more green type of technology cannot produce as much electricity as the previous methods. Dan since it's quite high tech, so cost pelaburan dia agak tinggi. From there, we can divide the sources into two groups. We have renewable sources and non-renewable sources. So renewable sources, they are natural, that can be used again. Okay, over and over again. We have hydro tadi, wind, solar, waves, ocean waves, even the tidal, biomass. Biomass ni maksudnya daripada bahan-bahan buangan. Those biomass generates methane yang boleh dibakar untuk menghasilkan, manaskan air dan generate steam. And of course geothermal. Okay, however, this with the exception of, not really exception lah, maksudnya this renewable sources ni dari segi scale agak limited. Even hydroelectric power plant, it depends on rain to generate electricity. Kalau macam hari tu Melaka duk rajin marau, tahap air dalam ampangan tu dah berkurangan, there is a certain level where they have to shut down the access tunnel to the hydroelectric generator. Sebab paras air kalau terlalu rendah, there will be a lot of silt, mud that will get into the hydroelectric chamber. So tak ada electric lah. Basically, you are at the mercy of the environment when you are going for renewable. Non-renewable, energy source that we are using up and cannot be recreated for a short period of time. So ni kira habis guna. Tapi kelebihan dia, we can upscale it. Kita boleh jadikan dia skala yang agak besar. Okay, and you are not limited to your environment. You can keep on producing as long as you have the sources. Contoh coal, natural gas, oil. These are the sources that we can use to heat up water and generate steam. However, these sources, the price will fluctuate. If you look into the international market, the price of coal, even natural gas at the market price, always fluctuates depend on demand. So that is why kadar harga elektrik yang kita perlu bayar tu berubah-ubah, because TNB is buying all these non-renewable sources at international price. Dan kita menggunakan elektrik with most of them non-renewable sources at a subsidized price. So orang Malaysia ni still beruntung sebenarnya. Harga elektrik yang dibayar tu sebenarnya adalah harga bersubsidi. Dan yang lebih untung lagi, syarikat-syarikat besar lah. These capitalist kan. Dia orang pun dapat subsidi sebenarnya. Orang pengguna biasa macam kita ni setakat guna untuk rumah ni berapa sen sangat lah subsidi yang kita dapat. So the industries are actually profiteering from this type of subsidies. If you have been overseas, di mana di negara-negara maju ni, there is no such thing as subsidies. Kena charge lagi adalah for carbon emission. You will see that the tarif of electric tu berubah-ubah from month to month. And it's relatively quite expensive. During winter months, myself pun, I did not use the heaters, the electrical heaters that much, because we know that electrical heaters will use a lot of energy. Dan kadar harga elektrik katakan di Australia tu sangat tinggi. Sebab yang provide tu adalah syarikat-syarikat swasta sepenuhnya. Government tak ada kena-mengena. Kat sana things can get quite pricey. Orang bekerja pun dah rasa mahal, apatah lagi orang-orang yang berpencen. Some of them can't even turn on peralatan, equipment untuk kesihatan mereka pun. Because tak mampu nak bayar bil elektrik. So orang Malaysia ni yang duk bising-bising TNB mahal dan sebagainya, basically they do not know what they are talking about. Bila dah keluar daripada tempurung ni baru dia tahu. Basically we are surrounded by ignorant people. Seronoknya duk Malaysia ni. Orang berduyun-duyun nak datang Malaysia ni. So those are the type of sources. We have renewables and non-renewables. Okay, tinggal satu lagi non-renewable ialah uranium, which is the nuclear power plant. Of course, uranium ni akan bertahan lebih lama compared to coal or other types of hydrocarbon. Maybe 50 years, 60 years, depend on the design lah. But when the uranium has depleted, it needs to be replaced by a new supply of uranium core. So walaupun tempoh uranium untuk habis guna tu makan masa yang lama, tapi ia tetap perlu diganti bila dah habis guna. So that's why it's also a non-renewable source. Okay, so this is a cross-section of a typical hydroelectric power plant. Kita ada air yang diampang. We have the dam itself. And then we have the water reservoir, and then we have the some sort of valve to stop the water from coming in if we need to do maintenance. And then water passage that would go down to increase the tenaga keupayaan tu lah. Goes down and gets into the where the turbine is. It will rotate the flaps of the turbine, which will turn the shaft, which will turn the alternator. And then the water will be ejected out. So once the alternator turns, it generates electricity, okay, at what, 20, 25 kilovolts. From there, immediately, but they do not want to put the step up transformer far from the source. You will lose your voltage like that. So normally the step up transformer is very close. It's basically at the dam itself. It's being sent immediately to the step up transformer to be boosted up to what, 400 kilovolts. And then the switch room will control the process, and then from these towers it will be immediately transmitted to where that electricity is needed. So this is another cross section of that hydroelectric power plant. Obviously, hydroelectric power plant ni there's a lot of designs lah, yeah. But the basic concept is still the same. Okay? Of course, you have these filters, intake filters to filter out all the debris from getting into the power plant. Okay, yang lain tu sama saja. It's just that you can clearly see the powerhouse. Powerhouse ni in this design is outside the dam. Ada yang inside, depending on the type of dam that they are building. And obviously you will have your step-up transformer in here and then being transmitted. So this is the process of generating electricity in the power plant. When you have this type of questions, you must be able to explain lah, from start to finish. You explain the components and then just how I explained to you lah, kan? From the water reservoir, then where it goes. So here, what's being explained here is not really that complete. So that's why jangan baca lah apa presentation slide pensyarah ni. Dia tak lengkap. It's just something to help or to guide the lecturers in presenting the topic lah. So it's mentioned here that the water pressure will come from the reservoir and then power station constructed at the bottom. Of course, hydroelectric power plant, mana dia punya power station kat atas? Power station mesti kat bawah lah. Kan? Ke atas mana air nak naik ke atas pula? Down, water passage will connect the reservoir and the turbine room. The water will run down and it will flow and push against the turbine blade. It will cause the rotor to spin. And the turbine will turn the copper inside the generator and generate electric current. And then transfer to the step-up transformer in the switch room. And then what power is being sent to the national grid. So the national grid is very interesting system. This is where the power being generated by multiple power plant is being pulled into this grid so that it can be sent to where it is needed the most. So by having this grid, katakan salah satu bahagian of the grid is down ataupun ada maintenance ke apa ke, kita ada alternatives to send the power where it is needed. But that is for later. So this is an example of yang inilah especially. It's a concrete dam power plant. Ini pun sama. This is the reservoir. This is not an what you call hydroelectric dam. This is just an earth-fill dam. Sometimes when you build a dam, ada kawasan-kawasan lain yang air dia akan naik dan air dia akan keluar. ikut kawasan tu. So kawasan tersebut pun perlu diampang, ditutup supaya air tu tak mengalir keluar. Bila kita sekat sini, dia keluar tang lain kan. So yang kawasan lain tu pun perlu disekat dengan ampangan. Enough with earthfill dam lah, ampangan yang menggunakan tanah lah sebagai sekatan, itu saja. Okay, so as you can see here, last time we visited this place, Kenyir ke apa. Yang ini is just the tip of the entire alternator installation. Ini ujung kecil je. Sebenarnya dia punya alternator turbine dia sangat-sangat besar. Okay. Here they have 3 ke 4 of these alternating turbines. At any given moment, they would have like 2 turbine in operation, 2 on standby. Katakan at peak hours, dia akan turn on lagi satu, so ada 3 turbine yang berfungsi lah, generating electricity. Dia akan leave one as a backup. So katakan belah malam tu demand dah berkurangan, they will turn off one turbine, so tinggal 2. This process happens automatically, is computer control. So tak ada siapa yang boleh on off that easily. Kalau pergi tempat ni pun tak ramai orang kan. 2 operator, orang 4 guard, 3 orang, tu je lah yang ada. Okay. But this facility is a strategic punya facility. Obviously akan ada security, polis dan sebagainya. And the technology being used here memang sangat lama. An advantage of hydroelectric power plant ni, the technology is so basic that dia boleh digunakan up to puluhan tahun, even 100 years, if it's being well maintained. Ini you tengok batang besi ni is actually rotating at 50 or 60 hertz. 50 tu maksudnya 50 pusingan. Okay, yang ni frekuensi 50 hertz. Maksudnya the rod is rotating 50 times a second. So that is quite fast lah. Rod ni dia menyambungkan antara dia punya turbine blade kat bawah tu dengan dia punya magnetic alternator kat atas. Kalau you tengok this rod, sama tebal dengan pintu. Okay, so you can imagine the scale of this turbine. Dia penetrate beberapa tingkat all the way down. So boleh tengok dia punya plate ni. 3-phase supply 50 Hz. Capacity 11,000 kilovolt. Rated. Tapi rated voltage 13,000 kilovolt. Lebih kurang 14,000 lah. Dia tak sampai 25 tadi kan. So it's just about 14 kilovolt. Dia tak nampak. Tapi sebenarnya this is quite old. So this is the isometric view of that turbine generator. Yang besi you nampak tu, yang ini. The turbine generator shaft that connects this blade to this alternator. Dia punya blade pun besar, macam blade kapal. You tengok saiz orang pun besar tu je. So they have an entire massive room for water to come in and spin the blades. And then kat sini kita ada wicket gate ni macam valve lah. So they're going to close it when that turbine is not in use. Maksudnya alihkan aliran air itulah supaya tak kena pada the turbine blades. So the water will spin the blade, the blade will rotate the shaft will rotate the alternator. Dalam ni of course kita ada copper cables, we have magnets. This is how electricity is generated. Especially alternating. So advantages of hydroelectric power plant, it's been in service for a long time, very long time. Memang dah pulang modal dah pun. Okay. But process of building a hydroelectric power plant pun makan masa. Bukan setahun dua, it takes many years to come out with a proposal. Okay. Operation cost is low sebab kebanyakannya automatic. Okay, guna komputer. Sale of electricity will cover the construction cost after 5 to 7 years. Related activities, water sports. Kan, bila kita ampang satu kawasan tu, obviously kita akan buat satu tasik buatan manusia lah. So kat sini macam-macam aktiviti, boleh ada tourist attraction, fish farm, mancing memang port orang kaki mancing kan ni. Ada banyak boat. They even have this macam rumah boat kot situ kan. Memang best, lepak-lepak situ, boleh mancing, masak barbecue ikan semua kat situ. Okay, very interesting. And then no pollution, meaning that it generates no nuclear waste or nuclear leaks masa proses dia beroperasi lah. Okay, tidak mencemar alam sekitar. Tak macam nuklear macam apa yang berlaku di Fukushima. Dia punya nuclear power plant dah lah kena gempa, lepas tu kena tsunami pula, 1-2 punch. Okay, totally nuclear power plant cannot be used anymore. And then kawasan di sekeliling nuclear plant tu pun tak boleh didiami dah for I think more than 100 years lah. Disadvantages, environmental damage. So pembinaan ampangan hydroelectric ni obviously akan memberi kesan kepada alam sekitar. Kita mengubah fungsi satu kawasan tu pada fungsi yang lain. So daripada hutan, dia akan menjadi kawasan tasik. So kesan dia pada binatang, pada pokok-pokok tumbuhan semua sangat besar. And then aliran air downstream yang dulunya tak disekat dengan ampangan, maksudnya aliran air dulu banyak air, tapi bila ada ampangan, aliran tu dah berkurangan. So bahagian downstream juga akan terkesan. And then native and migratory birds have increasingly, ni kesan pada haiwan-haiwan lah. Boleh menyebabkan haiwan kawasan tu yang tak boleh nak lari daripada aras air yang meningkat tu, they will be pupus kat situ lah. But bila dah ada kawasan tasik dan sebagainya, of course you will have new flora and fauna. Adalah burung-burung, migratory birds yang datang dan sebagainya. Industri perikanan pun boleh dibuat kat situ. Ada disadvantages, sediment build up and dam failure. Kawasan facility macam hydroelectric power plant ni memang it's a strategic punya facility. So kalau berlaku peperangan dan sebagainya, this type of facility yang akan diserang terlebih dahulu. So that's the vulnerability of this installation. Sediment, okay, dia punya, especially masa peringkat awalan ampangan tu sedang beroperasi, aras air tu akan naik. Benda tu bukan sehari dua, dia makan masa berbulan-bulan untuk aras air tu capai ke tahap dia yang sepatutnya. And then of course akan ada mendakan kotoran daripada bahan-bahan biologi, pokok dan sebagainya, daun dan sebagainya, lumpur. Benda tu makan masa untuk sedimen tu turun balik kan. Untuk projek ampangan saya terlibat dulu, dia akan makan masa 2-3 tahun untuk sedimen tu turun balik dan air tu jadi jernih. Dan sedimen ni kadang-kadang dia berkumpul di bahagian hilir sekali, maksudnya dia berkumpul di kawasan ampangan tu. So boleh menyebabkan ampangan tu, inlet dia tersumbat dan sebagainya. So sedimen tu perlu dibersihkan from time to time sampai sedimen tu properly mendap. And then failure. Dam failure ni you boleh tengok kat YouTube lah. Cases of dam failure memang berlaku due to improper engineering, dan kesan dia terhadap people downstream sangat besar. It can wipe out an entire township. And then population relocation ni juga berlaku di ampangan yang saya terlibat tu. Orang yang tinggal di dalam kawasan tadahan tu, So kita pindahkanlah dia ke township yang baru. So new homes, rumah baru, siap ada balai polis, balai bomba, jalan raya, semua free. So dia orang berpindah ke sana. So itu menambah lagi kepada kos ampangan itu sendiri. Sekiranya kawasan tadahan tu yang akan air itu naik, ada relik yang melibatkan sejarah dan sebagainya, relics pun akan tenggelam. Kalau tengok contoh China's Three Gorges Dam, okay, so dia jumpa banyak artifak di kawasan-kawasan tadahan tu. Tapi the government only gave them a couple of months untuk tarik keluar all the artifact yang penting-penting sebelum they start filling up the reservoir. Alright, so that is it on generation. Okay, power generation. I hope you can after this appreciate lah the facilities that we are enjoying right now. I will always try to relate what we learn here with our real experience sini. Besok kalau you ada rezeki mana tahu pergi further study dan sebagainya luar negara, you will see apa kontranya Malaysia dengan negara-negara maju lain. Alright, thank you for patiently listening in. Hope to see you again next week. Thank you. Assalamualaikum warahmatullahi wabarakatuh.